Hi, I'm Dr. Antonella Hatzich, professor in the engineering department at Pontifical Catholic University of Peru. Together with Dr. Santiago Flores, we have developed an invention on a procedure for the synthesis of zinc tannates from a hydrolyzable tannin powder source. Corrosion causes a loss of approximately 3–4% of the gross domestic product in industrialized countries, which is equivalent to $2.5 trillion. Classical anticorrosive paints normally contain inhibitors based on hexavalent chromium or lead compounds, which are toxic and have carcinogenic properties. This invention consists of the synthesis of metallic tannates, which are soluble or insoluble complexes prepared with vegetable tannins and metal ions. Tannins are non-toxic and biodegradable organic compounds that act as a ligand. For this invention, the hydrolyzable tannins have been extracted from a Peruvian source. Peru is the world's leading producer of this raw material. There are different types of tannins, but the hydrolyzable ones are sustainable sources since they are obtained from the pods and not from the bark of the tree, which reduces the impact of operation. The synthesis procedure is cheaper and more eco-friendly. We have prepared paints with these pigments of epoxy and alkyl nature, and we have applied them on mineral steel, new and aged galvanized steel. Paints pigmented with zinc tannates had an equivalent anticorrosive behavior and an outstanding adhesion, in contrast with formulations containing commercial pigments like zinc chromate. Zinc tannates, as a component of an anticorrosive paint, has proven, after electrochemical, accelerated, and natural exposure tests, to be efficient, green, and low-cost alternatives for the prevention of corrosion in marine and industrial environments.